Welcome to the next project, an Elliott Progress drill press. Made in London, shipped to New Zealand, I'd guess sometime during the 50s or 60s. This is a 5-speed belt drive drill press with a low speed back gear, giving a speed range of 2500 RPM down to about 45 RPM. Well, at the moment it has a speed range of 0 to 0 because there is an issue with the electric motor. I have never seen this machine run and I have no idea what surprises await. So let's pull it apart. It came with a couple of filthy old spares, a gear and a lever of some sort. That may be a good thing or a bad thing. It also came with a foot switch. I don't think I'll be retaining this, but I do like the idea of a foot operated cutoff. You know, for those times when both hands are occupied holding down a helicopter. Next, I remove all of the electrical components, starting with the forward reverse switch. A surprisingly clean drum switch lurks beneath. The metal power box comes off next. This feeds mains power to the motor, triggered by both the forward reverse switch and also the foot switch. The motor mounting plate is too large for the mounting plate on the drill press, so it has been secured through a secondary adapter plate. The motor is potentially going to be a major element of the restoration. It's a Canadian General Electric single-phase motor. So, made in Canada, it should be skookum, but instead it's just a smelly toaster. You, buddy! I haven't actually attempted to run the motor, but the guys before me said they stopped using the drill when the motor struggled to turn and gave off the telltale burning stench. I got lucky with the chuck. It's a genuine USA-made Jacobs chuck that looks to be in pretty good condition. It has a Morse taper number 2 adapter, which will also fit the tailstock on my lathe. There is no instruction manual for this drill press, no video to follow, so I spend quite a bit of time struggling with things like this stripped bolt, that it turns out doesn't actually need to be removed to strip down the machine. At this stage, I haven't figured out how the back gear assembly comes out of the machine, so I'll remove a few more obvious parts first. Starting with the main pulley. I use a gear puller because, you know, only a moron would pry something with a screwdriver. Here is a quick look at the top, my favourite kind of grime, the fluffy kind. There are 3 features poking through: the spindle, the top of the back gear shaft, and thirdly the column. The whole head of the drill just lifts off the column, so that one's easy, but the other 2, not so much. I decided to start working on removing the quill first, Presumably, to do that, I first must remove the quill handle and spring. Now, under this little black cover is a spring under tension. It's obvious now that the spring comes off as a complete unit, so I reinstall the little black cap to hold things together, and then undo a grub screw, and the spring assembly just slides off. That leaves the end of the pinion exposed. You can see that the spring has snapped sometime in the past. It was still functioning because the broken end was still catching on the pinion as it turned. And with the spring and depth stop removed, the quill is lowered out of the spindle. The problem with tapered pins is that you have to hit them from the correct end, which sounds obvious, but on a crusty old machine you can't tell which end is larger, and the pin may be so seized in that you have to hit it really hard. You only find out that you're bashing the correct end when the pin moves, or alternatively, the punch shatters. I decided it would be easier to tackle the spindle and bearings with the drill head on the workbench. At this point, I don't know how to get the cap above the back gear shaft out. I also don't know whether or not the spindle should be removed downwards or upwards. Both the spindle and back gear fought me every step of the way. I decided to tackle the spindle first. Basically, there is a hollow shaft that runs up through a total of 5 roller bearings. The obvious place to start is the outer sleeve and top bearing. There is no good way to do this, even if I had an internal puller small enough to fit inside the bearing. Because of the way the spindle is assembled, there isn't a lip to pull against anyway, so I guess screwdrivers are as good as anything. Ultimately, I decided that there was just no way the spindle was going to be pulled out from the top. So I moved on to the back gear shaft. There is a cap or plug pressed into the casing, which holds the back gear shaft in place. There is no option, it can only be pulled out. The only help is a threaded hole in the centre. At first I thought, great, thread a bolt down and it'll press against whatever is underneath and force the plug out, like you commonly find on brake drums. But this is not the case, it's just a blind hole. The only real option is a slide hammer, and hope that the thread won't strip. I don't have a slide hammer, so I quickly make up a tool. When this machine was new, the plug would have probably come out with a few gentle taps. It took a huge amount of brute force. Finally, a small hint of movement. And guess what? Removing the shaft itself. Same thing all over again. At least this time I was able to tighten the bolt against the top edge of the casting, thus pulling the shaft a wee way out before having to resort to the number 1 tool. So, with that taken care of, back to the spindle. At this stage I had figured out that the only feasible way to remove the spindle assembly was to drive it out from the bottom. After checking thoroughly for any hidden grub screws, I proceeded with the hitting. Now this is interesting. This shaft is driven by the pulley. It in turn drives an internal shaft through to the drill itself. When the back gear is in use, the driving gear actually spins around this shaft. The shaft, I guess, has worn to the point that someone has built it up with brazing and then turned it down smooth again. It's an ugly repair, but I'm not sure if I will touch this or not. There's no feasible way to remake the shaft from new because it has internal square splines. I could turn this shaft down undersize and sleeve it, and then turn the sleeves down to a perfect finish, but there are risks involved, and I will never find a replacement if I mess something up. I'll think it over. Now, before I touched this project, I knew there were 2 issues to overcome. Firstly, the dead motor, and secondly this, the smiley face of neglect across the drill table. I will fix this, or I'll mess it up and you'll never see it on video. Now this drill press isn't exactly a precious piece of machinery, but still, I'd like to do this properly, which means welding cast iron. And yes, I know you can weld cast iron with nickel rods. Hell, you can just fire the MIG at it if you're a heathen. It's solid. That was heavier than I expected. And that's about it. Reduced to a pile of parts. Not too bad. Thankfully, all of the internal components look okay. There are no chipped gears or anything like that. So I'll see you at the next video, where I promise something will turn out shiny and clean. Before the curtains close, check this out. I found this piece of debris on top of the head. Another screwdriver tip. Dumbass.